So next today we'll write about the refraction through a rectangular glass slab. Refraction through a rectangular glass slab. Okay, write down this. Write down everyone who are online also. Lateral displacement. And write down the diagram. Okay, here this is a glass slab denser. And again we have here air. It is a region. I lateral displacement. So the perpendicular distance between the emergent ray and incident ray. When the light passes, out of the glass slab is called lateral displacement. In the glass slab, the refraction takes place twice. First, when a ray enters the glass slab, enters the glass slab. And second, when exits the glass slab. When exits the glass slab. Okay. So here, once I again explain, listen, refraction through a rectangular slab. Okay. So rectangular slab, if you consider like that, this is a glass slab. Okay, some thickness it has. So what happens first, there will be refraction two times. When light from the air, okay, when the light from the air passes through the glass. So there will be change in the medium from air to glass, correct? So there will be refraction. So at that time what happens? Light is moving from rarer to denser medium. So it is moving from rarer to denser medium. What happens? The light is moving from rarer to denser medium. So their light bends towards the normal. Second time, when it is coming out of the glass slab. So when it is coming out of the glass slab, light moves from the denser medium to the rarer medium. That is from glass to air. So this time, light bends away from the normal. So once it bends towards the normal and the other time it bends away from the normal. So two times there is bending of light. Okay. Now, first time it is from air to glass, correct? Second time from glass to air. So, between the two medium only there is refraction. Both the times there will be the refraction within the two medium itself, correct? So, here the amount of bending it happens first time. It will be towards the normal, other time it's away from the normal. But amount of bending here and in the second time will be the same. Why? Because it is between the same two medium. Understood? Again I repeat, see, a refraction through a glass slab where what happens? There will be refraction for two times. One from air to glass, second time from glass to air. First time it bends towards the normal. Second time it bends away from the normal. But amount of bending I told no, it depends on the medium, right? Between the two medium. So amount of bending for the first time and the second time will be the same. What is the reason? Because first time is between the two medium. Second time also it is between the same two medium. Okay, so amount of bending towards the normal and away from the normal will be the same. So that is why, so the ray which is coming out, right, we call it as emergent ray. The ray, after two times refraction, that it comes out, right? That ray only we call it as emergent ray, this ray. Okay. Now incident ray, just extend and see. See, that ray only comes as emergent. By chance, if there was no glass slab, incident ray would have come straight. Correct? So just extend, that's why I've written dotted. Just extend and see that incident ray, if it has no glass slab, how it would have come. That ray, if you compare with the emergent ray, which is actually coming out, you observe that they are parallel to each other. That's what that concept is trying to tell. Understood? Now, now that parallel to each other, but there will be some shift. Without glass slab, this would be the line. With the glass slab, this is the line. There is some shift, but they are parallel to each other. Okay. That shift, they call it as lateral displacement. So that shift, they call it as lateral displacement. Whenever they ask about deflation, you just write this. It's a perpendicular distance between the emergent ray and the incident ray. When the light passes out of the glass slab, is called displacement. There is lateral displacement. Okay. But if you ask to explain, write the diagram and explain. Diagram. The extent of bending of the ray of light. So, the extent of bending of the ray of light. So, the extent of bending of the ray of light. So, the extent of bending of the ray of light. So, the extent of bending of the ray of light. So, the extent of bending of the ray of light. So, the extent of bending of the ray of light. So, the extent of bending of the ray of light. So, the extent of bending of the ray of light. So, the extent of bending of the ray of light. So, the extent of bending of the ray of light. So, the extent of bending of the ray of light. So, the extent of bending of the ray of light. So, the extent of bending of the ray of light. So, the extent of bending of the ray of light. So, the extent of bending of the ray of light. So, the extent of bending of the ray of light. So, the extent of bending of the ray of light. So, the extent of bending of the ray of light. So, the extent of bending of the ray of light. So, the extent of bending of the ray of light. So, the extent of bending of the ray of light. So, the extent of bending of the ray of light. So, the extent of b At opposite parallel faces, opposite parallel faces is equal and opposite. So emergent ray is parallel to the incident ray. But shifted sideways. Sideward slightly. Now we will study about the lenses. So until now we studied about the refraction. That is this phenomenon, how it will work. Next we study about the lenses. How we studied about the mirrors, right? We will try to study about the lenses. So there are spherical lenses. Okay, we are trying to study about the spherical lenses. There are two types of spherical lenses. One is the convex. Write down this. Convex lens or converging lens. Converging lens. Okay, second one is the concave lens or diverging lens Okay. So convex means it will be bulged on both the sides. Okay. So concave means the surface where, okay. So the surface will be bulged. So this is a convex lens. Concave lens. In the concave lens, we have it is like a cave. Then we have a concave lens. Okay, convex lens and concave lens. One very important thing you should know is, see, we studied about concave mirror and convex mirror also. Correct? So there light was reflecting. First thing is light was reflecting. That is, the light which hits the mirror, it reflects back. It comes back to the air itself. But here, since it's a lens, see, light will pass through the lens here. Light is passing through the lens. Whatever spectacles you wear, it is a lens. What is the spectacles? Like people wear, it is a lens, not the mirror. See, the light is passing through that lens and afterwards it is reaching the eyes. Correct? So that is a lens. So here what happens? First light it passes from air to the lens, then from lens to air. Correct? So there is actually a refraction here. It is not the reflection what happens in the lens, it is the refraction what happens in the lens. Understood? No? So whatever happens in the lens, it's the refraction because light is passing through the lens. So from air to the lens, that is air to glass once, glass to air once. So this is the refraction what happens in the lens. Okay. So now we will try to see when if you keep the object in some distance, what happens to the image? So whether it's virtual and direct or it is real like that. Okay. Real and if it is inverted and where is the position of the image, all these we try to learn here. Okay. And one basic thing what you should observe is convex lens here, it's a converging lens. Can you tell which was the converging mirror what we studied in both? Yeah? Tell me which is the mirror, converging mirror we studied? Tejasri or anyone? Online people?
Concave mirror.
Correct. Very good. Concave mirror was the converging mirror there. Here, convex lens is the converging lens. So, when you study its properties, everything, concave mirror, what is there? It is very similar to convex lens. Understood? So, when you compare concave mirror and convex lens, they are similar. If you see, okay, and convex mirror is similar to concave lens, then it is easier to study now. If you have that comparison, it is easier to study. Understood? Because convex lens is converging, concave mirror was converging there, and concave lens is diverging, and there we studied like convex mirror, it was the diverging mirror. So that is why the opposite way it works. Okay. Converging means what? Trying to bring all the rays to one point. Diverging means trying to divert the rays from some point. That point only we call it as the focal point. Okay. Where light tries to converge at one point, right? That point we call it as a focus for the convex lens. And the point from which it appears to diverge, we call it as a focal point for the concave lens. For the center point, we call it as the optic center. The center point here, we call it as the optic center. And if you observe, it is like the two spherical mirrors. If it is combined, you can make it as a lens, right? So, if I, for this part of the lens, if I complete one spherical mirror, and here also I will complete one portion. So, you have the two actually combined together, it forms a lens. Okay. So, you can observe for this portion, there is one center of curvature, correct? And even for this, you have one center of curvature, C. So that is C, correct? You will have two center of curvature here. Okay. Now, and there will be focus for this, that we can call it as F. And here also there will be focus for this portion of the lens. So that is also one focus. So you will have two focus and two center of curvature. C, instead of C, we call it as 2F here. Okay. See, again I repeat, convex bulged on both the sides here. This is a convex lens. Okay. So for this part of the lens, we have some center of curvature, correct? And instead of C, we call it as 2F. Okay. And this portion of the lens will have some center of curvature, because if you extend here also it will be there. So this is also one C, that we call it as 2F. Okay, and this portion of the lens, we have some focus F, and this portion will also have some focus. This is also F. So we have two focus points and two center of curvature here. Okay. That much if you understood now. And the center of the lens, we call it as optic center, O. The center of the lens, we call it as the optic center, O. What you are trying to search, you are getting? So trying to find what? 2F, it is there. You will get. I'll just write there. Understand. This much you understood. Center of the lens, we call it as optic center. And here we have one F here, 2F. This is, and we know that focal length and radius of curvature, it is 2 times. Remember, we studied R is equal to 2 times F. Correct? That 2F only we are directly writing. Okay. Here also the same way. And whatever lens we are studying in this book, no, both the distance here, this center of curvature is same as this center of curvature. For simplicity, we are studying like that. Understood? You can get different center of curvature, but here, whatever we are studying, it is like this. Okay, so we have some optic center, which is the middle of the lens. Then we have the center of curvature, we call it as 2F, and we have the focal length on both the sides. Okay. And the line joining the optic center and the center of curvature, that is 2F, we call it as the principal axis. So hope you understood. We'll write about the definition. Write down definitions. Optic center. The center point of the lens. The center point of the lens is known as its optic center, is known as its optic center. Okay. Next, center of curvature. The centers of the two imaginary spheres of which the lens is a part are called radii. Sorry. The center of two imaginary spheres of which the lens is the part. 1 second. Are called center of curvature. Are called center of curvature. So there will be two centers here, of which the center is of the imaginary sphere. If you complete that sphere, where we get the two centers there, that only we call it a center of curvature. Then comes the radii of curvature. The radii of the two imaginary spheres, of the two imaginary spheres of which the lens is a part. The radii of two imaginary spheres of which lens is a part are called radii of curvature. Radii of curvature. Next is the principal axis. Principal axis. The imaginary line joining the two centers of curvature is called principal axis. Is called principal axis of a lens. Next comes the focal length of the lens. The distance between the focus the distance between the focus and the optic center and the optic center of lens is called focal length of the lens is called the focal length of the lens. Image formation in lenses, okay, using ray diagrams. Using ray diagrams. We'll study about that. So first thing we'll see how the rays will pass. Even in the mirror we saw if it is parallel to the principal axis, it used to pass through the focus, right? And here we consider the thin lenses. Thin lenses means it means see this is small portion of a very big lens. We are considering the thin lenses, that is in a very big sphere, some portion we will take, small portion we will take. That's how we have considered here. So it's a thin lens. Okay. Now we will first consider the convex lens. And convex lens, what we studied, it is a converging lens. It is a converging lens. Okay. So this is the optic center, and you have focus. And this is the center of curvature, we call it as 2F. Similarly here also we have the focus point, and this is the 2F point, that is the center of curvature this side. Okay. Now any ray which is coming parallel to the principal axis, any ray parallel to the principal axis passes through the focus. Here, see, any ray parallel to the principal axis, it passes through the other focus here. Okay. Write down this first one. So rays which are parallel to the principal axis after rays which are parallel to the principal axis after refraction will pass through focus, that is principal focus. Okay, it will be refracted parallel to the principal axis. Any ray passing through the focus will be refracted parallel to the principal axis. Any ray passing through this optic center, it goes without deviation. Same here. Yeah. 2 here. See, some people here write this as F1 and oh yeah, but okay, write better capital letter only, right? Textbook it is like that. Hmm. Some people write all as the same F. Some people they will write it as F1 and F2. It's the same thing. See here F and it's the same F we will write. Sometimes some people will write it as this is F1, this is F2. It's the same thing because you can have different F. You can have, it's not like you can't have, but for simplicity, what and all we are studying, they have the same focal length on both the sides. So that is why it is the same F you can write or F1, F2, your convenience. Because each school will write the different thing, don't get confused. And always remember while you are writing, what is the distance you have here, right? This is only focal length. This distance and this distance will be the same. And even on this side. Think if it is, this is 5 and here 5. This is also 5 and this will be also equal to 5 like that. All those distances should be same while you're writing. Okay. Write down now. Ray passing through the optic center passes without deviation. Ray passing through the optic center passes without deviation. Okay. Okay. Then we will write about this also, no? About the we studied about written about convex, no? Concave also. We just write the diagram. So write down. Concave lenses. Concave lenses. Okay. So in the concave lens, so what type of lens is a concave lens? It is a diverging lens. It is a diverging lens. Okay, so this is an optic center. F. F. 2F. Okay. So, any ray parallel to the principal axis, listen here this, any ray parallel to the principal axis, they appear to diverge from the focus point. Okay, they appear to diverge from the focus point. That means if any ray parallel to the principal axis, they appear as if it is coming from this point, focus point. Okay, actually it will not ray come back here, but it appears as if it is coming in this direction. Okay. Ray parallel to the principal axis appear to diverge from the focus. Here actually like diagram sometimes it's difficult to write. Here this portion should be thin as much as possible. You write thin only. Okay. Sometimes I will be not able to write so neatly here diagram, especially other things I can write. Okay, when you are writing, write it little bit neatly. So this thickness should be less because we are studying about the thin lenses. Okay. Now this is an optic center. Okay, optic center. Now, any ray passing through the focus, it appears to diverge, okay, parallel to principal axis. any ray. Okay. So first one what we wrote, okay, parallel we have written, right? Next, in the direction of the focus, then it will be parallel to its. In the direction of the focus, it will be parallel to principal axis. So this is in direction of this focus. Okay, in direction of that, but from here only it will refract. Okay, if it is in that direction, then it will be parallel to principal axis. Okay. Last one, right now. Any ray passing through the optic center, it goes without deviation. Ray passing through the optic center passes without deviation. Without deviation. A ray passing through the optic center passes without deviation.
Here we will end the today's class. Do not forget to subscribe the channel. If the content of this channel is useful, please like the video and share with your friends. Thank you.